Lesson 1-1. Learn to evaluate algebraic expressions. First, let's go through the vocabulary. You can choose to either write it down now or go back and fill it in later. A variable is a letter that represents a value that can change or vary. The coefficient is the number multiplied by the variable. Here's a quick little example of those two vocabulary terms. The 30 is the coefficient out in front that you would multiply by. The n, which is the variable. An algebraic expression has one or more variables. It's also important to note right now an expression does not have an equal sign. That would be an equation. So we're just dealing with kind of one half of an equation right now as an expression. In the algebraic expression x plus 6, 6 is a constant because it does not change. You learned in kindergarten what 6 represented, and it still represents the same thing today. It's a constant term. To evaluate an algebraic expression, substitute a given number for the variable and find the value of the resulting numerical expression. Basically, solve it. So here's some examples given on your worksheet. Evaluate each expression for the given value of the variable. X minus 5, and it wants us to substitute x equals 12. So the first step is to substitute 12. Anytime x occurs in the expression, I'm going to put in 12 for that. So 12 minus 5. My next step is just to subtract those values and get 7. Remember order of operations when you're dealing with more than one step problem, PEMDAS, and I highly recommend you write that at the top of your homework sheets. P is for parentheses or any grouping symbol. E is exponents. Remember multiplication and division have the same importance moving left to right. Same with addition and subtraction. Same importance moving left to right. So here's a two-step problem. 2y plus 1 for y equals 4. Anytime y occurs in the expression, I'm going to substitute 4, which is the first step. Once that 4 is in there, I can go ahead and put parentheses or grouping symbols. Since in my original expression, there was no arithmetic symbol, so when no arithmetic symbol is given, it means to multiply. Order of operations tells me to do that first, and the last step is to add. My final answer of 9. Let's give this a try again. On your next worksheet in your homework packet is a big table that's given. I'm going to solve the same expression 3 times, 3 different variables. So whenever a variable is given, remember, you can choose the value or it can be given to you to substitute in. So you can do it over and over several times. So if I know that 5 guests were coming to a party, or 6 or 7, what are my different outcomes? This also gives me my table for order of operations. So the first thing for n equals 5 is I'm going to substitute. Order of operations tells me to solve parentheses. 5 plus 2 is 7. Order of operations then tells me to multiply. 6 times 7 is 42. And the last step is to subtract 4 to get 38. Go ahead and try the next ones. First step, substituting. Solve your parentheses. Go ahead and multiply. And your final step, subtract. I urge you to pause the video at this point and try the last one on your own before turning it back on to check your work and answer. Okay, moving on to the next type of example. Sometimes you have more than one variable in an expression, and we can still use order of operations and substitution to solve it. For example A, 4x plus 3y, for x equal 2 and y equal 1. First step, again, always to substitute. And since the 3 and the 4 are coefficients, though, that's going to mean to multiply. So you can add in a multiplication sign or parentheses. Go ahead and multiply 4 times 2 and 3 times 1. And your last step is to add to get your final answer of 11. Example B, 9r minus 2p for r equal 3 and p equal 5. Again, the 9 and the 2 are coefficients, which means to multiply since no arithmetic symbol is given. Substitute your values for your variables. 9 times 3 minus 2 times 5. Multiply those. 27 minus 10. And your last step is to subtract. Answer 17. Where might we use this in the real world? Here's a physical science application which might come in very handy for you guys this year. Use the expression 1.8 C plus 32 to convert the boiling point temperature from degrees Celsius to degrees Fahrenheit. Since the variable C is given in my expression at the beginning, I'm going to assume that means Celsius. So if I go on and read the problem, boiling point of water at sea level is 100 degrees Celsius, then I've assumed correctly that the small c in the expression is for Celsius. So I take the expression given from the problem, and I'm just going to substitute my 100 for C. 1.8 is the coefficient. I'm going to multiply that, just simply moving my decimal point 2 places because of the 2 zeros in 100. So 180 plus 32, last step, add. And since it's a word problem, I need to have the correct unit or label for my final answer. Water boils at 212 degrees Fahrenheit. Now that was an example given at sea level. We live higher than sea level, but we can also look at another example. The boiling point of water at an altitude of 4,400 meters, much higher than sea level. There's not as much air pressure at that altitude. Those molecules in the water can get excited a little bit more easily and boil at that lower temperature because they're all excited and boiling in there. I'm going to use the same expression from the previous page, 1.8c plus 32. But this time I'm going to substitute 85 for the C. Use a calculator, use your noggin, pen and paper, whatever it takes. Multiply 1.8 times 85. So I have 153 plus 32. Add that together. Again, it's a word problem. Please include the correct unit and label. Water boils at 185 degrees Fahrenheit at 4,400 meters. You guys have 3 problems left on your homework packet for notes. Get those completed and get checked by me when you come in.